Hey guys, it's all around Danny. In this video showing you guys how to solve a system of equations using matrices. So here we are, I solved the system of equations, and the answer would be x equals 4, y equals 3. Now I'm not going to go through the steps, but as you know, solving system of equations you can do either with substitution or elimination. But I just wanted you guys to know the answers, so when I solve with the matrices we can check to see if they are right. So, first thing off that you have to do is that you have to write out three different matrices when you're using matrices to solve system equations. First one is your coefficient matrix, second is your variable matrix, and the last one is your constant matrix. Now the coefficient matrix consists of all the coefficients in your equations. Of course they have to be simplified so that the variables are in the same place. So if this one was written, let's say negative 4y minus 24 equals 3x, then we would have to write, plus 24, then we would have to add the 4y, and then we would end up getting this equation. So you have to simplify to make sure that everything's in the same place. But once it looks like this, all you simply do is that you copy the coefficients onto the matrix. So depending on how many variables you have, that would determine how big your matrix is. So in this case, this is a 2 by 2 matrix. That's how I would write the number 2. So it would be, right here is a 1, there's a 1, so this would be 1, 1, here's a 3, here's a 4, this would be a 3, 4, and that is our coefficient matrix. Now our variable matrix consists of of course our variables, and they are written in the same order that they go from left to right in the equation. So here we have our x first and then our y. So our x would go on top and our y on the bottom. This would be a 2 by 1 matrix. Now of course this also varies depending on how many variables you have. And the last one is our constant matrix, which is simply the answer to these equations, which is 7 and 24. This is also a 2 by 1 matrix, and this of course varies by how many variables you have in your equation, how many equations you have, and things like that. So, the way we're going to solve this is that we're going to find the inverse of our coefficient matrix, and then we're going to multiply the coefficient matrix by the constant matrix. So I'm going to give myself a little more room, so I'm going to open up a new page. So we know that our coefficient matrix is 1, 1, 3, 4, and our variable matrix is 7, 24. Okay, so of course to find our inverse matrix, we first have to find the determinant. So we multiply diagonally 1 times 4, which is 4, minus the other diagonal, minus 3 times 1, which is 3, equals 1. So now what we do is that we place the determinant as the denominator of a fraction. So now we multiply a revised version of this matrix by 1 over 1. And now the revised version consists of switching these two numbers in place. So our 4 will go on top, our 1 will go on the bottom, and multiplying these two numbers by negative 1. So it would be negative 3, negative 1. And now we multiply this out to get 4 over 1, negative 1 over 1. I'm making it fractions unnecessarily just so you guys can see the steps. And then this of course would be 4, negative 1, negative 3, 1. That was really pointless. I'm just multiplying it by 1. But I just wanted you guys to see the steps. Alright, so now what we do is that we multiply this matrix by our coefficient matrix. And very important, you have to keep the inverse matrix first. You cannot switch the order around, so you cannot multiply the constant matrix by the variable matrix because you will get a different answer. Because of course, multiplying matrices is not commutative. So, 7, 24. And now we're going to put our answer up here. Let me give myself some room. Alright, so here's what we do. If you guys don't remember, we would multiply rows times columns. So this would be 4 times 7 plus negative 1 times 24. And then the other row times the same column because they're normal columns. It would be negative 3 times 7 plus 1 times 24. If you didn't follow what I was doing, I was simply moving down the rows and the columns at the same time. So we start at the first element of the first row, first element of the first column. Then we moved down to the second element of the first row and the second element of the first column. And we did the same thing over here, same thing over here. If there was more columns, I would have done this. I would have simply moved down the columns like so. Alright, so now we multiply this out, and we would get, we would get 24 minus, pardon me, oof, that was bad, 28 minus 24, and then negative 21 plus 24, and then of course this would equal 4 and 3, like we remember on the last page, 4 and 3. Now we know that x equals 4 and y equals 3 because of the place of the variable matrix. So remember, variable matrix was x and y, and our answer would be in correlation with the place where our variables were. So that's really it when it comes to solving system of equations using matrices. Thank you guys for watching. I'll see you guys in the next video.